We're going to do numbers 2 and 4 here. Numbers 1 and 3 have answers there. Of course, as you can tell, this process is pretty serious. So if you just have the answer written down, no credit. Here we go. So number 2, is there a number we can factor out of all 3 of those? Nope. No variable either. That one doesn't have a variable. So we tried to take out a GCF. Notice we have 3 terms though, and the highest degree is 2, so we can try this fancy-dancy method where we now, since our coefficient of the x squared or r squared term in this case is bigger than 1, we can multiply a and c together and put that on the top of our diamond. So 5 times 6 is 30. On the bottom we have negative 17. Now realize here, folks, we're looking for ways to multiply to positive 30 and add to negative 17. So 1 and 30, 2 and 15, 3 and 10, 4, 5, and 6. And these all, these are ways to multiply to 30, but they would never add to a negative 17. Well, remember, we can change both sets of factors to negatives, because a negative times a negative is a positive. So, hey, this combination right here, negative 2 and negative 15, that multiplies to 30, and it adds to negative 17. So that is the answer. Now, back in the day when our leading coefficient was 1, we took those answers and put them right into our factored form. This time, though, remember, we need to actually take those solutions to our diamond and drop them in place of the middle term. So instead of writing down negative 17r, I'm going to write down negative 2r minus 15r. I'm going to get these factors out of here. Whoa. Right. So that goes in place of our middle term, our negative 17r. And those do combine to negative 17r. So it's equivalent. I'm not ripping this polynomial off at all. This negative 2r becomes like a minus sign. So we drop down our first term, we drop down our last term. So now what I've written down here in red is equivalent to this. Exact same values. But now we can look at factor by grouping because we have 4 terms. Remember, if the third term is negative, add the opposite. So it's a negative 15r plus 6 inside the parentheses. And now take the most out of, or factor the most out of you can out of these 2 terms. So out of this first 2 terms, you can factor out an r. So you're left with 5r minus 2. What can you factor out of this? Well, 3 goes into both of these numbers. However, notice that this first term in this binomial is positive, and this one's negative. So I think we want to divide by a negative 3. When you divide by a negative 3, we'll be left with, in the parentheses, with a negative 15r divided by a negative 3 is a positive 5r. And then after that we have a positive 6 divided by a negative 3. That's a negative 2. Check that out. Now our binomials are matching, correctly so. So then we put together these factors, these GCFs out in front. R minus 3. And then bring down one of those factors, or one of those binomials, excuse me. So there is our factored form of this polynomial right here. And if you went about and FOILed it, I'm seeing that this first multiplication gets you 5r squared. Good, that takes care of that. Here you get negative 15r and negative 2r. Negative 15r with that multiplication, negative 2r with that multiplication. What's negative 15r combined with negative 2r? Negative 17r. That's beautiful. And then last but not least, we have a negative 3 times a negative 2. A negative 3 times a negative 2 is a positive 6. Boom, that is correct. That is the solution. So let's try one more. Oops, I copied the wrong thing. It's kind of nice having this template down there perhaps for you. Of course, this is in your notes, so that'd be a really handy thing to have out as you try numbers 1 and 3 in a second. But I'll do number 4 with you. Definitely not going to have a GCF coming out of this thing, because that 1 right here, or this k right here, is a coefficient of 1. So multiply your a and c together. That's negative 2 times 10, which is negative 20. That's my top number. 1 is the coefficient of the k there, so that's a 1. So two numbers that multiply to negative 20 and add to 1. That'd be positive 5 and negative 4. Now those get a k with each one. We're going to replace this single 1k with 5k minus 4k, because that's equivalent to 1k. Then we drop down the 10k squared. So this 5k is positive, so I'll put a plus sign in front of it. And then we drop down our negative 2. We've just written a polynomial that's equivalent to this one right here. Well, why do we do that? Again, now we have the 4 terms, so we can do some factor by grouping. So group the first 2, group the last 2, but make that 4 a negative. That's a little messy. I'll put a plus sign. Oop. Watch me cheat a little bit with the different colors we have. Zoop. There. Plus 4k, negative 4k minus 2. All right, here we go. Let's try to factor these bad boys. So we can pull out a 5k from the first binomial. We're left with 2k plus 1 then. And we can factor out a negative 2 from this one, because I see they're both negative, and I actually want them both to be positive to match this one. So instead of pulling out just a 2, pull out a negative 2. And then negative 4k divided by negative 2 is positive 2k. Negative 2 divided by negative 2 is positive 1. All right, put your factors together. Bring down the 2k plus 1. Boom. I can check the, I'm going to actually go backwards here to check this polynomial. If I multiply the last 2, I get my constant. That's negative 2. And sometimes we make mistakes with the signs, with the positive or negative sign in here, so that's just a good way to double check it. And then I'm going to multiply these 2 together. That gives you negative 4k. And those 2 give you 5k. Negative 4k and 5k. Add to 1k. Hey, we're good there. And then this multiplication gives you 10k squared. So when we multiply all the terms, or distribute the terms respectively as we should, we get, and we simplify, we get 10k squared plus 1k, or k, minus 2. That is totally the correct answer. Whew.